Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you all about the basic principles of loop optimization. Let me get into the topic. Basically, loop optimization is the most valuable mission independent optimization because programmer's inner loop takes bulk of time of a programmer to perform a task, right? It actually uses this optimization. The meaning of optimization you all know well, which makes the code effective based on the mission independent values, right? The purpose of using this loop optimization is to decrease the number of inner loops when the running time of a program may have the improved variations, that is improved even if they increase the amount of code in the outer loop, right? Even if the code is improved based on the outer loop, how does the outer loop gets involved in execution, right? So this operation can be performed with three categories. Number one, code motion. So let me get into this process. We have seen the same process in different manner in principal source of optimization as well as the process of code movements, right? Basically what this code motion does, it is used to decrease the amount of code in loop. That is the only purpose, right? So whenever the code motion has been applied, this transformation takes a statement or else the expression which can be moved out of the loop, which use to make the code more effective. Let me go with an example. Say for example, how does the code movement is actually working, right? The basic operation of all this optimization technique will have one principle, that is whether the loop has a limit or does a loop doesn't have a limit. Say for example, while the condition here it is, I am taking this condition while condition I is less than or equal to limit minus 2, for example, right? I have taken this example for simple understanding, right? So while I is less than is equal to limit minus 2, there is a task is has to be performed, right? This is before, I can call this is before. How this code, this condition code can be made evaluated or else the experience of this particular code can be improved, right? So this is before. Now I am going to write a after code. You know well what to do. Basically I am going to move some process here which takes a execution time, that is instead of runtime which takes an execution time can be moved out. Say for example, a is equal to, I am moving only the limit minus 2, this particular value out of the loop. Now you have a condition while I is less than or equal to a, the process is over. So here the value has been consolidated and this value has been stored in a. Now the running time of this process or execution time of this process can be looked into a. Now a have execution process which has a limit minus 2, so it is stored in a. Now you check the condition and run the process. Now this gives a valid output before what we have in this code. This is all about how the process has been done in code motion. Fine. So let me get into the next process in loop process, loop invariance. Here you can see the values, how this optimization loops can be done based on replacing the variable from inner loop. So the best example I can give here it is induction variable elimination. Let me take you to this looping process. Now say for example, I have assumed that I am having a 5 block loop statement. Say for example, the first block j is equal to m minus 1. This is a series of loop, right? So again j is equal to n. We have some values to be performed, that is temporary variable t1 is equal to 4 asterisk n and u is equal to a of t1. Assume that this is block 1. Okay, so I am getting into the next block so that you will come to understand what exactly the loop variant has been operated here, how this variable is eliminated, right? This is the second block. Again I have some interrelated values from block 1. J is equal to j minus 1, t4 is equal to 4 asterisk j, and then we can have t5 is equal to a of T4, right? And then the condition, if T5 is greater than U, then go to block 2. So this is block 2. So it is again asking if T5 is greater than U, the condition, then again go to B2. So again it starts from the inner loop, from the beginning, right? This is block 2. Assume that in block 3, if I is greater than or equal to J, then go to block 5. So this block 5 is the output process. Say for example, this is block 5. This is if or else. Else condition we have B4 for example, right? So these are all the two different statements we have. So two different process has been done. So here let me tell you, here the process has been done. Assume that this is a loop code which has 5 blocks. Block number 1 we have initialization variables, and then block number 2 with temporary variables, and the condition has been checked. If T5 is greater than U, go to B2, that is an inner loop which performs itself. So we are going to see it whether this process can reduce the number of addition in a loop. Okay, the addition in a loop, because it improves both code space as well as the runtime performance. Say for example, so this is the code which is we can say it is without inner loop reduction. So I am going to have the inner loop reduction now. Here I am starting here. So basically I can say I is equal to m minus 1. I started with the same code, so you can keep on verify parallelly, you can see that, right? So again j is equal to n. So again I am taking this t1 is equal to 4 asterisk n. Again I have this u is equal to a of t1. So I am going to just check what process has been repeated in the second loop, that is T4 is equal to 4 asterisk j, which is there already in the top loop, that is B1 block 1. So I am going to just shift this T4 is equal to 4 asterisk j. Most important thing is this is block 1. The most important thing is whatever we do in optimization, we should not disturb the regular structure of the code. That is the most important point. So let me take you to this block 2 here. So I am going to write the block 2 variant. You can see how it is differ. J minus 1. So here it comes. T4 is equal to 4 asterisk j. So I am going to write the T4 here, which doesn't make any change here. You can see that T4 minus 4, which has the same value, right? So here this changes. I am not just changing the structure. That is a point. But the code has been improved. So here you can see T4 is equal to 4 asterisk j in the block 1, right? So whenever it is necessary, it will take the performance here itself. It doesn't move to the block number 2. So here finally what we are going to do, we have a check, condition has to be checked. Before that, T5 is equal, I am going to write the same thing, a of T4, which has the same value. So again, if T5 is greater than U, go to, so we have gone to B2 here. So that is the same, which has the same, B2, right? So you can able to check all the condition here. Whatever I am writing here, you can check the condition which gives which value. Okay, so here which has a loop. Okay, again if it is going to be, if this condition is true, it will go here. Or if this condition is true, again it is going to be, block number 3 here. So I have forgot to mention, this is block number 3. Write the block number 3 again here. If I is greater than or equal to j. So go to block number 5, right? We have 2 blocks here. Assume that this is block number 5 and this is block number 4. So the condition here it is, this is the whole thing is block number 3. The block number 3. Now check the condition. If T5 is greater than U, go to B2. Right, that is an inner loop which is going to perform the same loop again and again. If this doesn't happen, go to here. If I is greater than or equal to j, go to B5. This is the part which is going to have a positive result, or else it will check the condition, the else part, B4, which makes the loop more effective than this previous one. You can check this. It has a jump variant here, but it doesn't have a jump variant from block 1 to block 2. Okay, so this is how the induction variable elimination can be performed, right? Okay, let me take you to the last topic in this loop variance, that is reduction in strength. We have seen so many reduction in strength process in our optimization technique. Let me take you to the new example. So basically what this reduction in strength used to replace the expensive operation, that is a point here. It is used to replace the expensive operation by the cheaper one of the target mission. So what happens if it is replacing the cheaper one? The addition of the constant is cheaper than the multiplication, right? So we can replace the multiplication value into addition, right? So let me take you to the example, best example we can see. So we are making only one part here, that is we are making the multiplication value into addition, right? I am going with the same example. While the condition I is less than 10, right? The 10 the condition has been checked. Here it is the strength has been with higher value. Say for example j is equal to 3 asterisk I plus 1. Okay, so you can rewrite this particular thing in your way. So I'm going with an example so that the easier way where you can understand. Okay, so now a of j is equal to a of j minus 2, for example, right? I is equal to I plus 2. In this example you can see that where exactly the strength can be reduced only in one point, that is this, right? So here you can reduce the strength, that is 3 asterisk I can be reduced into cheaper strength, that is plus value. So this asterisk has to be replaced into plus value. So I'm going to write the same example in adjacent way. So this is without reduction. Okay, so here it is reduction, right? So let us see how this reduction has been performed. So I am just moving this particular value out of the loop. Okay, so for example s is equal to 3 asterisk I plus 1. So I'm just moving this out. So the computed value is in s. Now I have written the same values here. Say for example here it is. Okay, so I'm going to write while I is less than 10. Okay, the condition I'm going to write in the same way. So again you open a loop where you can find j is equal to 3 asterisk I plus 1 has been moved here with the value s. So I'm replacing j into j is equal to s, right? So a of j is equal to a of j minus 2. This is not going to make much change in this particular process, right? Again I is equal to I plus 2, right? So forgot to close the braces here, right? So I is equal to I plus 2. Now if I close a braces here, this code is a wrong code. We have moved this particular strength out, but we have not computed it. Now this s value has to be always improved based on the condition, right? Initially 3 into I, that is 3 into I is initially 1, for example. So 3 into 1, 3 plus 1 is equal to 4. Now this value has to be improved and condition has to be satisfied. So s is equal to, I am just improving this multiplication of this value. S is equal to s plus 6. Now you check the condition. Every time the value increases, now s will have s is equal to s plus 6. Whatever the changes you are going to do here, it will be increased because the I value has been increased. I mean I values has been computed and then the condition checked and then it is improved. So next thing is what? I value will be 2, right? I value will be 3, I value will be 4, but instead of that the value has been plussed here, right? So anything you do here, the value of s is equal to s plus 6, the value of 6 will be multiplied here, you will get the same answer. So this is how the performance of the optimization can be done in based on n number of strengths, n number of reduction process. So this is all about loop optimization, where we can find the 3 basic example with code elimination process. Thank you.